with where the elements of the SVG are associated with data, and we'll see what that means. But I think we'll also see that that's just the sort of the start of what you can do with D3s. Let me take some. I'm going to be doing two things here. I'm going to be making an HTML file where we're going to see a lot of the pieces, and then over here I'm going to take some notes. One of the things about D3 is it's really trying to extend the power of other existing technologies. And so in order to talk about D3, we're going to end up talking about HTML, SVG, CSS. We'll talk about JavaScript a little bit, in fact, a fair amount. And then only then will we really get down to the D3, where we'll start doing wild and crazy things. So let's start with HTML. So I'm writing an HTML document, and this document right now has one tag, which says this is HTML, and I'm going to add another tag, H1, which means header, hello world. /H1. Save this text file. Okay, I should have mentioned I'm using a text editor here. I happen to like Atom. It's a nice cross-platform, completely free text editor. And I've saved this text file, and now over in my browser, I'm going to open up that text file from Documents, D3 Presentation, Main. So there's our web page. It's kind of nice to take a second to think about how straightforward it is to write a web page. We sometimes forget how easy it is to write a cool web page. If anything, if you get anything out of this talk in the next hour, I hope it's that you take a few minutes and write a little web page that you load into your browser. And by the way, if you're interested in posting it on the web for free, I can show you how to do that. So if you want to make free internet sites, there are ways to get your page hosted. Under HTML, we've already covered the H1 tag, and I guess we talked about the HTML tag. So what's next? Let's talk about SVGs. So I'll make an SVG. SVG is another kind of tag. SVG stands for Scalable Vector Graphics. It's one of the ways to draw pretty pictures in an HTML document. SVGs, there's two commands I want to cover right off the bat. One is the rectangle command. Now, you can request a rectangle, but to get a particular rectangle, you'll need somebody looking in and deciding no thanks. You'll need to set some attributes. So far all we've done is use tags. Now we're going to set some attributes. X equals 10, Y equals 10, width equals 100, height equals 100. So to make a rectangle, you need to know about these 4 attributes. I'll save that, hit reload. What just happened? Let's open up our browser's secret panel, where these are the developer tools, and take a quick look at our DOM here. We have a body that's the whole thing. Inside the body, we've got our H1 tag. It says I've got some text. It says hello world, and inside of that, we've got an SVG document. Sorry, SVG object. And it contains a single thing called the rectangle. I want to take a second to talk about the coordinate system, but that might be, let me throw in now a little CSS. So it's time for our document to have sections. There's going to be a head, where I'm going to put some CSS, and all of this is part of the body. So I'll slap body tag down here. So in this top part, we're going to introduce CSS. We're going to say, I would like all my SVGs to have a border of 1 pixel solid black. Oh, gotta say that we're inside a style tag in order for this to be recognized not as part of my document, but rather my CSS. Normally we load CSS in as an external file. For these examples, we won't need to do that. We'll just have it right here in this one file. So there's our SVG object. There's our rectangle inside the SVG. And I'm going to just talk briefly here now about coordinate systems. When we said this rectangle should be 10 units in X and 10 units in Y, that meant the upper top corner of the rectangle should be over 10 units and down 10 units. So X axis is our usual horizontal x-axis. The y-axis is a little bit reversed from the way we look at a lot of diagrams. Normally we think of y going up. For graphics, we often have y going down, and that's going to be a source of confusion for us as we lay out charts. So we're going to have to keep track of that minus sign. But just to be clear here, if I move my rectangle to x equals 50, hopefully everybody knows what's going to happen when I reload. It jumped over 50 pixels to the right. Another thing I wanted to do is add some attributes to my SVG. I want to set its size. We just took the default size. I'd like to set the width to be more like 600. So we can get 600 units of pixels. And the height of the SVG, we can set that to be 200. See if that changes the size. Yep. So we've got a bigger SVG. We understand. So let's write down what we've covered here. SVG's got a width and height attributes. It's got the rectangle tag, and in the rectangle we talked about the X, Y, width, height attributes. And now we're going to introduce the circle tag, where we're going to talk about the CX, CY, R tag attributes. Okay, so sorry for making that tight, but hopefully people can see that enough. So, circle. And again, I'm covering all this for many of you that write web pages all day in, day out. This is all old hat and maybe boring. For others, it might be a good review, and for others still, I'm sure on this call, that maybe this is the first time we've used a circle command in an SVG. So I hope everybody doesn't mind. We're going to be leveraging these tools very shortly with E3. So here's circle, CX, I'm going to move it over a lot, CY is equal to, let's say, about 100 units down, and R is, let's say, 30. That's my circle. Everybody picturing it before I hit reload? Ooh, that's not where I pictured it. I want to move it over more. Let's make it 300. Okay, nice. So let's keep going here. Let's make a couple more circles. Copy. And this circle, we'll put 500 over, and maybe one more rectangle just for fun. And this one, we'll make it smaller, more like 30 by 30. And next, we make what? 250. What does that give us? Everybody got it? That's what SVG is? Those two tags? Nice. Let's do some more CSS.
Is SVG part of HTML5? How does the browser understand that tag?
Yeah, it's just part of HTML.
Oh, okay.
So it's fully supported tag. Let's turn the rectangles blue. Well, we can select by type. We would like all our rectangles to be filled. So one of the hard things here is for a given selection, what are the different tags that will have some effect on it? That's a long, complicated answer. We won't get into it. So the only takeaway I'll ask for everybody here is that we have at least these particular tags for these objects. So we can set the fill to be blue. And okay, the rectangles turn blue. Nice. Now let's turn the circles red. And it's that easy. We've styled our picture. You know, if we comment out this SVG, you can sort of imagine that we've got a lot of power. We can draw all sorts of cool things all over our page. It's kind of fun. What we just covered here under CSS was a type selection. We've selected by type, circle, rectangle, SVG. What if it's not by type that we want to color our objects blue? Maybe I would like both rectangles and this circle to be blue and the other circle to be red. Well, then we can do a class selection. So there's a special attribute called class. So for any object in your HTML, you can define a tag name and a value for that tag. Class is special in that CSS recognizes it, looks for it. So I'm going to introduce this guy. I'm going to say class is equal to blue thing. Again, I can make it anything, whatever I would like for that class. Class is special. Blue thing is just some string I made up. And I'm going to give all of my objects this class, and then I'm going to say instead of selecting by type, I'm going to select by class, which means I use a dot, and I say blue thing should be blue. And while I'm at it, I'll introduce the anything with the class red thing should be red. So right now, all of our objects are blue. If I said that this guy was supposed to be red, boom, that one guy's red. So we have type selection, we have class selection. I think we're ready to introduce D3. Is everybody comfortable? Hopefully everybody's feeling, yeah, this is pretty good, I feel pretty good. We're about to rock and roll. Okay, let's introduce some D3. So I'll just quickly go to the D3 site, and we'll come back to your, hopefully at the end, and look at some examples. But I'm just going to grab this tag that says introduce D3 into my page. So in the head, I'm saying I've introduced a new tag for us here called script, and tag, and we're using in this case the source attribute. It says I'd like to load this external file from the web, and if I reload the page, nothing's different, got no errors, nothing seems to have happened, but actually something very important has happened. I now am going to start writing some JavaScript. So I'm going to again use the script tag, but this time without this source attribute, and I'm going to start writing JavaScript right down here. So the first thing I'm going to do with D3 is sort of, and for those of you that happen to know what jQuery is, it's a jQuery-like behavior. I'm going to make a selection of part of my DOM and do something to that selection. In this case, I'm going to append an H1, and I'm going to give that H1 some text. Hello again. So, if you've never written a line of JavaScript, that's probably very cryptic. But the idea here is that we are chaining a set of function calls. I said, I asked D3 to go into the body, the entire object, grab, at the very end of it, append another H1, and then in that H1, I would like it to have the text hello again. So if I reload my page, that's nice. There it is. Hello again. Right. So D3 lets us do some nice jQuery style selections. I'll make a quick note that if I selected, I also mentioned the append function and the text function as examples. There's a difference between select and select all. Select just will pick one. Select all will pick all. So I could, for example, say d3.select all rect. And then I'm going to introduce a new one called style fill green. So there's a style function, which is going to apply a style attribute. So I'm going to hit save, hit reload. Now look at that. All of my rectangles just turned green. So let's take a quick look at the DOM to see what happened here. So we have a head, which has just our styling and the library loading. We have our body. In the body we have the hello world. We have an SVG. We have our script. And then we have this new hello again, even though we never explicitly told the body I want to have a hello again. We use JavaScript and D3 to append a hello again to each one tag and attribute, no attributes, just tag no text. But in the SVG also, we have a rectangle, and if we look over here in how the styles are being calculated, when I click on this rectangle, we'll see that it's still classed as a blue thing, and it's still being asked to render as blue, but it's also got this style fill equals green that's overriding the blue of the class selection. So just good to know exactly how that works. The circle's still blue, that circle's still red. You can see what line of code in your HTML is applying that. Okay, now I think we're ready. Let's dig into some data. So I'll take this out. I don't think we'll need anything here. Var. It says I'm going to create a variable in JavaScript. And I'm going to say my data is equal to an array, and I'll give it some numbers. 5, 12, 17, 4. Here's some data. So d3 dot select all. I'm going to select something that doesn't exist. I'm going to select some things called some things with the class of dot. I have nothing that's got class equals dot yet in my document. In fact, I'm not going to do anything else. I'm going to just reload the page to show that, by the way, we got rid of everything because I deleted everything in my SVG. So this is where we're at. Now, secret command number 1 from the D3, the data command. For all of these selections, I want to associate my data with this group selection, this set of selections. Secret command number 2. slightly differently. The enter command. Attribute, so append, just let me type this and then I'll explain it. Append a circle, give that circle an attribute. We're going to need to define that cx. We're going to need cy. We're going to need a r. And just to start with, let's say 50, y is 50, radius is 10. So what, if I hit reload, actually there's sort of nothing seemed to happen. I was expecting something to look like it. What this is trying to say is select a bunch of things that don't exist, associate with my data with those things, and then for each one of the data points, do the following commands. Append a circle, and apply these attributes to that circle. So it's going to, basically this treats these set of commands as a loop. Now, I'm sort of surprised I don't see a circle. That. There they are. Oh, I know why, because I said append it to my document, not to my SVG. So let me select my SVG. So var SVG equals e3.select. Now I can select all SVGs, and then everything that I'm doing to this will apply to all SVGs. I'm going to say that this particular SVG is special. I'll call it, I'm going to give it an ID equals the chart, and then I'm going to select by ID. So just like in CSS, you can select by ID, and instead of the dot, you use the hash. Same thing for D3. I'm going to say select the chart. So I could have just said SVG, but I made it a little more complicated here by introducing the idea of ID selection and doing that here to select the SVG, this particular SVG. Then I do exactly the same stuff, but I'm doing it on this D3 selection, and now I have one circle. Is that surprising that I have one circle? I don't have one circle. I have 4 circles right smack dab on top of each other. One associated with each data point. So now we're going to introduce the secret sauce. We've actually seen 2 pieces of secret sauce. The data command, the enter command. I'm throwing one more and it's going to be really tasty. I didn't have to make that a constant. I can make that a function of, I'll tell you what D and I are in here in a second, but I is the index. We're iterating over the 4 different things. So I is going to be an index, so I'm going to return I times 50. Does anybody have a guess what that's going to look like?
Spaced out by 50.
Bingo. Space out by 50. Because each circle now is going to get its own x position based on I. So as I was first 0, then 1, then 2. And the fact that the first one got pushed off to the side there is because we index from 0. So just to move it onto the screen, I'm going to go say I plus 1 times 50. That's nice. So nothing special about any one of the attributes. We can apply this function concept to any of them. So I could return, so the first argument, I've typed this right, returns purple function. So the first argument, D, is the element in my data. So it'll be, the first time it's called, it'll be a 5, the second time it's called, it'll be 12. So I can just return D here, and we have a visualization of our data. We just created an interesting visualization of the data. The data, if you remember, started off 5, got a little bigger, got quite big, and then got very small again. Maybe this could be planet sizes. And we've got a nice way of laying out planet sizes, or maybe it's populations of certain countries. We can see an example of that later. But the point is, we've already started to introduce a way of looking at our data.
So we can do the animation.
Where'd you get I from?
Okay, two questions at once. Jerry asked, where did I come from? So it's part of the D3 magic that these functions that are passed into the attribute function expect and receive 2 different arguments. The first one is the data value, and the second one is the index over the data set. So the data is an array, and by the way, and we'll see this maybe later,
I didn't see that. Thank you.
Sure. The data, in this case, happens to be numbers. It doesn't have to be. It can be objects. It can be arrays of arrays. It can be very fancy things. We're just starting simple. Sorry, I missed your question.
Yeah, just say that this can lead into animation. Right? You can program animation. Now.
We will see some animation coming up shortly. So yes, it only gets better.
Because my daughter is cooking and processing, so it's very similar.
So we need a group selection, and it's a great point. I should probably, I'm going to go ahead and give these guys a class, attribute class of dot, and this will sort of so there's. Now each of the circles that was created as part of this loop has this class dot. And that, so unfortunately dot maybe is an unfortunate word, but we are selecting, when we do the selection, we need to put the little period in front of the object, and that says select things with the name, with the class of whatever follows. So the class itself only needs to be dot. So I don't know if you remember, but when I put the rectangle inside the SVG, I just gave it the class of red thing. But then when I did my selection up here, I said dot red thing. So I didn't have the extra dot for that. And the significance of it is later. I don't know if we're going to get to it today, which is when we want to update this data with new data. We'll want to be able to get back to these objects and associate the new data points with the old data points, and perhaps like animate the data going from this old data to this new data. Did that answer your question, Rich?
But there isn't a class called dot.
So you're tagging that with dot on with the class here. So do you need to select all at all? Could you just go svg.data? Or do you need to select all for something?
So yeah, so the SVG object is quite a different object than the return value of this function select all. That's returning to me a group that is ready to be associated with an array of data items. If I did it to the SVG, nothing good's going to happen. I don't know what exactly is going to happen, but it's going to be bad. We need to do a select all of some thing.
But that's not part of the DOM yet, right? The select body to find the body tag within the DOM, but over here it's not going to find dot.
And if we do a select body or select SVG, we're going to just get the one object, and that isn't going to associate with a set of data the way a group selection is with the select all.
Is there any relationship between the class selector in line 38 and the way you're adding the class attribute in line 42?
So I made these the same word, and by the way, I could call it whatever. I just thought these little circles looked like dots to me, but maybe I can call them planet, just to maybe if that's a point of confusion.
But do they have to match?
They don't have to match, but when we get to the updating process, we're going to want it to match.
Okay.
It'll be convenient.
So at the start here, if no planet exists, what's it selecting to make the four?
Well, that's the magic of the data and the enter command, is that even though there's nothing in there, the enter command is saying, oh, for every data point where I don't have a corresponding element, I'm going to go ahead and do whatever you ask, which probably means I'm going to make a new element. So actually, I'm not expecting to get all the way to the full update process in today's one lecture, but in the full update process, we're going to make new elements for each of the new things in the data set. We're going to change the values of the ones that we found, and for elements of the data set that have gone away, we'll call the exit command, which is where we'll probably just remove the corresponding element from the SVG. But that's sort of advanced. Wasn't hoping to go that far today. So I'm glad everybody's asking these questions, though. I hope this is helping. The general idea from where we've gotten so far is that you can define a set of data, you can append objects based on that data, and D3 will go ahead and make those objects for you as part of the enter command, so that we get this nice association. So maybe to be clear here, I can double down my data, and D3 does the magic way, just get the extra dots. Okay, with that, I think it's time to do more of a scatter plot. So what I would like to have happen is have the data spread out by I on the x-axis and go up a certain amount by y on the y-axis. In the way we learned in 8th grade, right, when we had the x-axis and y-axis, y is going to be up, which is going to be a point of confusion because our SVG, remember, has y going down. So let's see, what am I going to need here?
So you're starting off with a confusion.
It always starts off, everything starts off confusing, then once you get it, it's all easy. Let's introduce width and height. Y-axis. Well, let's start off just simple here. If the radius of all these guys were going to be 10, we could just say that. We'll just fix the radii to be something. But now, the height of these guys are going to vary based on the data. And how much? Well, let's think about this. So let's start off simple here. I'll just say it's D. With that change, can everybody visualize what they would see? You're expecting the dots to still be spread out in X pretty nicely, but the Y value, the radii are all going to be the same, but their Y value, which is right down, is going to vary depending on the value in the data. Is that what you were expecting? Kind of, sort of, hopefully. Some people nodding. So what do we see is that this guy is 5 pixels down, this guy is 12 pixels down, this guy is 17 pixels down. Now, we have this whole big region that we defined for the SVG. Seems like we ought to scale to use the full area. So maybe instead of D, I should see the biggest number in there is 17. If I multiply it by 10, not that, if I multiply D by 10, I get a little more spread in the usage of my real estate here. Okay, that's interesting. And then, of course, we're going to want to introduce a minus sign because we would really like them to be higher for each value. That didn't work.
You need to add the height, plus 200. 200 minus that?
Thank you. So the total height, which is the width, which is the height, minus the value that we wanted, tells us now that this guy is scaled, 5 scaled units. It's actually 50 pixels high. This guy's 120, this guy's 170, this is 40. So they've been scaled up. I think we're ready to introduce, I want to introduce a width and a height for the, so I'm going to say var width. And I don't want to introduce a new variable. The SVG already had a nice width. So I'm going to just request to learn what that SVG's width is using D3. And using a command we already saw, the attribute command, what we saw was that if I pass a second argument that said apply this value to this width. But if I only pass one argument, it just says return to me the value that it currently has. It's going to be returned as a string. I'm going to want to convert it to a number by using a JavaScript convention that you throw in a plus sign in front of the string and it tries to convert it to a number. So similarly,
I'm sorry, you're getting the attribute, the width attribute of what?
Of the, thank you, of what? Of the SVG.
Oh.
That's a great question because I have the wrong thing there. I wanted the width and height of the SVG. And so now the width and height can be set wherever and we are responsive to it. What will I do with that width and height? The X value,
Do you have a var for height?
So
No
I-
semicolon?
Constant.
Oh,
yeah,
Fine.
I won't go into, a lot of opinion in the world about how you should use the var command and whether it's better to use comma, but either one would have worked. I could have put a semicolon here and said var height, or I can do the comma notation. Maybe to simplify, I'll do it this way. So now I have a width and a height, and now I want to introduce a next really simple but powerful, cool idea from D3. It is not from D3, I'm sure it must exist in the world lots of places, but it's such a powerful thing. It's the scale object. So I'm going to introduce an X scale, and I'm going to say D3, I would like a linear scale. So I just call this function and it returns to me a linear scale, any sort of linear scale, but to make it useful, I need to define the domain and the range. The set of values that are input, that's the domain, and the set of output values that are the output, that's the range. So for the X scale, the input, so the domain, is going to be 0 to the number of elements, my data dot length. And the range is going to be 0 to the width of that we defined above, which is just the width of the SVG. Okay, so what's that do for me? Well, now I can say, I don't want this complicated conversion that I have to do in my head from pixels to other units. I can just say, I would like my X scaled I value. And what's interesting is before I had this X scale, if I doubled my data again, it would have gone off the side, right? Because I would be up to like 15 times 5, 50. But now that I have this scale, I can actually double the data again. Copy, comma, paste, save, and it stays in bounds because we've scaled the data. Simple idea, super powerful. Let's do a Y scale. Var Y scale equals, again I'm going to do scale linear. And the domain, what's the domain? Just paying attention. We would like the data to not go off the bottom of the screen for different values of the data.
So the highest value, 17?
Yeah, so the domain will be 0 to the max of the data. And the range, what's the range?
Height of the.
The height of the whole thing, although we can save ourselves an annoying minus sign if we say that the range is the height to 0. Embed the minus sign right there. So there it is. So now we can return, instead of all this noise, y scale of the value. Pretty cool. And what's cool here is that if I change the data, let's say that's now 45. There we go. We see that that one data point is now way bigger than all the rest of the data, but everything else just scaled. Everything just fell into place. Let's take a second to review that nothing really magical is happening in terms of HTML here. All that's happening is we're building this SVG. It's got more and more circles in it. They all happen to have the class that I assigned. They've got positions that are defined by these functions, and they're all got the same radius. Okay, nice. Now, one thing that's bugging me is that some of my circles are getting cut off. So there's a standard, so the guy that wrote the D3 library is a PhD, he was a PhD student at Stanford. His name's Mike Bostock. Smart guy, obviously. He ended up working for New York Times, actually, and applied D3 to do all sorts of very interesting visualizations of different kinds of data about what's happening in Afghanistan, politics, information about how NFL picks and fashion. It was really fun to look at. We'll hopefully have a few minutes to look at some of those examples. I'm not late yet, right? This is only 4:15. I'm still doing all right. Anyway, he's introduced a sort of a standard technique for dealing with this. So I'm going to introduce what he uses. Bar margin is equal to an object. So JavaScript, for those of you that have not done a lot of JavaScript, this might be strange again, but objects in JavaScript are just name value pairs. The top will say it's 20. The right is equal to is 30. Left, bottom is 30, and that is 20. So now we have this margin object. Oh, I need to introduce one more concept in SVGs. Let's go back to our original SVG. I want to introduce okay, so here's a rectangle, x equals 10, y equals 10, width equals 100, height. This is our original rectangle. Let's have it back. So there he is. And I'm going to introduce one more circle. Sorry for trying to retype this. You always say to watch that painful process of me trying to type circle. CX is 110, CY is 100, and the distance R.
CY?
Thank you. R equals 30, and CY is the center of the circle, and this is now this rectangle, it's a circle. It's picking on me. All right, so I've got a circle and a rectangle. Let's see if I see that circle and rectangle. So these are called out explicitly. What I wanted to introduce was the group object. So there's a tag in SVG, standard HTML now, where you can group a set of things. So everything between the two group, the start and ending group tags are part of a group. You can do some styling by group, but what we're going to be leveraging is the transform. So you can add a tag called transform, and that's a string that you can say translate 50, 20. Any guesses what that might do? Hopefully everybody's thinking about exactly that. The square and the circle, just the square and the big circle, are going to move over 50 units and down 20 units. So let's see if that happens. No, of course not. Transform, translate. Let me see if we can debug why.
It's a typo. Transform is yes.
Transform. Thank you, Dick.
Yeah.
Transform. Transform is, like I said, you can introduce any tag you like, and so there's no error there. There's nothing wrong with introducing a transform, but the group HTML says I don't know anything about it, so I'll ignore it. But we wanted to translate, and just for the record, we can also rotate, let's say in degrees, the group, and we can scale by a factor. Ooh, pretty big. If you want to scale by 5. Okay, fine. We now understand the group object. Where was I in my notes here? HSVG group tag, which by the way is G. And inside the group tag, we talked about the transform attribute, where we're allowed to introduce a translate, rotate, and scale. Okay, so why do I care? Well, we're going to use this group concept to create, we're going to create a group in our inside of our SVG. So we have an SVG, we define this margin. I'm going to define a new width and height, which is the width minus the margins. This is the width, so the margin dot left and the margin dot right. And then similarly, the height, I'm going to remove margin dot bottom and margin dot top. So our width and height have become a little smaller by the margin. And then I'm going to, instead of using SVG, I'm going to introduce G. I'm going to take my SVG, I'm going to end a G, a group, but I'm going to transform it. So I'm going to introduce this transform attribute, and I'm going to translate it by how much? Well, I wanted to move over margin dot left, and then it's plus quote. So this plus, oh, it's so confusing JavaScript, but I'm now concatenating strings with my plus sign, not adding numbers. But now I'm going to say comma plus the margin dot top. Finally, plus quote close semicolon. So, and then the only last thing is that instead of adding my planets to the SVG, I'm going to add them to my group. So let's see what happens here. Oh, next thing I'm going to do is get rid of circle and rectangle, which unfortunately seems to make my whole screen blank. As if maybe I have a typo of some sort. Error. See an error. Let's look at our DOM, see if we can spot the problem here. Undefined transform. Okay. RG. Still hard on this limited real estate I have. Feel free to call out the bug. This looks like that.
What's the G?
Is it quote G in line 45?
And quote G, thank you. Yes, two good observers. Good eye, reload. Now I'm getting a proper error, missing the semicolon or the parentheses. So that was closing my attribute function. Aha, okay, back to progress here. So, more wheels. Perpetually. And a better mouse. Okay, so my circles aren't cut in half. That's the takeaway here. I've given myself a little margin and I can make that bigger. If I wanted to give myself more room on the top, I just increase my margin and I have a little more space. And by the way, we can put the border back to see if we really have how much space we have. Reload. So if I go back to a margin of 20, this top thing should get closer to the top. It's only 20 to the top. Now we're ready for axes. We should put some axes. We've gone to the trouble of making this beautiful graph, but it's got no axes. So D3 has a couple of facilitators for building axes. What's an axis going to look like? Well, normally it's got a horizontal or vertical line. It's got some tick marks, maybe got some labels. So that whole horizontal line, tick marks, and labeling, there's some utilities that you can choose to leverage from D3 to do that. What is the point of one of these axes? It's to map. It's when you draw a line 3 inches long at the bottom of your graph, and then you mark and you say that corresponds to 10 miles, and that's 20 miles, and that's 30 miles. You're making a scale, usually often a linear scale, from one space to another space. And in our case, we're going to want to map data to pixels. So we happen to have that right there. We happen to have the perfect thing. The X-scale object is going to be the perfect input to the D3 axis object. So to do this, I'm going to take my group, it's the group, and I'm going to append a new group inside that group. I didn't really talk about that, but in SVGs, groups can be nested inside of other groups. So I'm going to nest another group, and I'm going to say call D3 scale axis bottom, but it needs some function to understand what to map from where to where, but this is going to be our horizontal up one, so I'm going to say the X scale is the object. Let's see what that does. Oh, interesting. We put an axis, of course, at the top. What? Why would we put an axis bottom at the top? Well, let's see what happens if we said axis top. Oh, I flipped the tick marks. So it has nothing to do with where the axis shows up. That's up to you. We're going to choose to move it here in a second. But the axis top, axis bottom sort of indicates where it's expected to be relative to the data. So by saying axis bottom, I'll put the top tick marks underneath. Now, this axis is way at the top. I want to move it somewhere. We know how to do that because it's inside of a group. So what do? Apply an attribute. Transform. And we're going to translate. How much do we translate in X? So in X, how much? In X?
0.
None. Nada. Zilch. But in Y, we want to translate the height. So let's just say that. And then let's have the closing parentheses. So we load. Yeah. An axis down there at the bottom. Corresponding to the data. You seem to have an off by one error. Why is that? Because the domain is to my data.length, but my data.length, we started indexing from 0, so maybe we should say my data.length minus 1, so that goes all the way to and fine. Are we ready to do, that was so easy, let's throw in a y-axis. So, we're going to add another group. We're going to not need to translate it probably. We'll see. The input is the y-axis, but any guesses for what kind of axis we want? Sure. Load. Oh, it's a little tight in there. This is where our margin's kind of nice. Let's introduce a little more space on the left for our axis to fit. Let's look at 40. Okay, that's pretty good. I think I want to make it a little bigger. 60. Now what I'd like to do is move that y-axis just a little bit off to the side. I don't know if it's too close to my dots. So I'm going to, I can either transform the axis like we did before, or I could just give myself a little fudge factor here, just to point out another way of doing it. Say that the x scale should only go from 30 to 50. And that it's going to push everything in a little bit. That's nice. Okay, so it's a good point to take a breath. We've covered a lot of concepts. Let's make sure I got them noted here. JavaScript, I talked about var, I talked about array, I talked about function calls. D3, what else have I introduced? Oh, in SVG, I guess we covered the group tag. I guess I'll point out that we can nest groups. Introduce this margin idea. But hopefully everybody sort of feels enough context that they almost feel like I can go back to my desk, whip open a text editor, and draw a graph. Do I have the pieces? Maybe I could do that. D3 is not a charting library. If you were interested in just making charts like this, there are easier ways to do it. You don't have to learn all these pieces. D3 comes to life when you start adding the animations, when you start asking yourself, what are some new and different ways that I can let the user interact with my data, click on things, and pull and push and move around. The world of opportunities, so D3 is just a set of tools that start to let you build creative and interesting new ways of looking at information. So that, and by the way, although we oriented ourselves here on SVG, there was nothing in the syntax that was SVG sort of specific. We could have been, for example, writing on a Canvas element, if you happen to know what those are. Or we could have been maybe plopping text as different headings, or build a table, or there was nothing specific in the syntax that limited our thinking to SVG, other than they've got these nice little tools for making an axis, for example, if you're sticking to SVG. Let's do a little bit of animation, and then let's look at some real examples on the world. So, what I'd like to do is start off there. See our planets, as I call them. But I would like, after I show the planets, I'd like to transition to some different things. So I can use the transition function. Transition. I'd like to make a transition, and I can specify some parameters or some defaults, but I'm going to specify that I would like 3,000 milliseconds to happen before the radius changes to 100. Anybody got a guess what these next pieces of spice give us? Something's gonna change. Hit reload on the page. Whoa! Blow up, that's pretty good. Radius is 100, it's maybe too big. What about radius equals 30? Let's start off, radius was equal to 2, and let's give ourselves
scaled, right? Scale with a linear.
Right. Good point. These are just hard-coded. There's no rule that says I couldn't introduce a function. We'll see that in a second. But I'm going to give myself a 1 second delay before the animation happens. Hit reload. Got tiny little dots. Interesting. This should only, I mean, this is just gratuitous. This is, there's no meaning for that particular animation. It's just sexy. What is meaningful is when you introduce some sort of interaction and the data point shifts. For example, if I had a little more time, maybe we'll see if we run out of time, I might want to represent the same data in a polar coordinate system. So arrange the data in a circle, and the bigger the value, the farther away it goes, and the smaller the value, the closer it is to the center of the circle. So we use an XY representation for this data. Nothing wrong with a polar representation. We could then, very easily actually, introduce a button that says click, and all of our data shifts from the one organization to the other organization. That's not gratuitous. That's continuity for the user. They're interested maybe in this one data point. They're looking at that tall 45, whatever that represents for them. And then they see it shift over to polar, and they can follow the animation, and it has meaning. So this is getting into the philosophy and religion of data visualization and what's meaningful and whatnot. Sometimes what you'll see are animations that just do these bloop, which is really cute the first time, but after the 5th time it's really annoying. And other times you see animations where it's like, wow, that added some meaning for me. Let me grab an example. Maybe one of the best first examples. How's everybody on the phone doing? Are people still engaged? People here? Any questions? I guess that answers that.
This is awesome. I want to go these examples.
Okay, good.
Plug.
H503. Yes, so to start with, I'm going to show you some of the things we've been doing with D3 in our application. So, Leader Central is a piece of functionality that is not yet shipped. This is showing averages of students' data over time. So, students use the student app report, and we would like to represent for the district administrators or school administrators or even teachers how much how much time on average their students are using to the application. Bunch of different things we can click on here. We start off in the monthly view where we see a little bit more than a month of data, and each of these dots represents a week of activity. Let's start off in the weekly view where each dot represents a particular day. In this whole district, nobody's using the app there on these last days of March. But let's scroll back in time here. So that's the first thing that I would point out as a D3 thing here is that I've got 2 visualizations. One is this lower visualization that's kind of like a scroll bar, and the upper one is is sort of a typical line chart. And I'm able to scroll on the lower and affect the upper, and by the way, vice versa, I can scroll on the upper and it's bidirectional. That's kind of cool. So in this view, with the weekly button pushed, each data point represents a day. I can click on it and see how much time that the students on average in that district spent working with the student app application, and it reports the number of sessions we were using. By the way, this little gray section you see there is a weekend. All the weekends are marked in gray, so they have a certain width when we're in the weekly view, but when I switch to the monthly view, they're still there, but now they're a little skinnier because we've got more data on the thing. Another thing to notice here is that on the whole overview button, you can, in very light gray, I don't know if you can see it very well on the screen, but in very light gray, behind you can see all the data. So it starts off kind of high and goes lower and then goes up really high, and we can see that that's a map of the master data. So in the weekly view, I saw that, yeah, nothing's happening right now, but by looking back in time over here, I saw that there's these mountains. I could scroll there and see what was happening. Oh, interesting. And then similarly, right at the beginning in November, it seemed like we had a spike of activity with the student app application.
So where is the data coming from in Verify?
So the data that populates this graph is coming from Intellify. So every time a student uses a student app application, some information is fired off to Intellify. Intellify is grabbing up this data and creating streams of information. And then when we say we want to render a report, they give us the top of the stream back so that we can render this information. So that's just one example. Let's look at the D3 site and look at some other examples. This is one of my favorite. So this is kind of complicated. There's several elements to this. The x-axis is income per capita inflation adjusted over time. The y-axis is life expectancy. Each of these circles represents a different country. I happen to know a couple of them because I've been playing with this thing. This big circle in brown is China. This not quite as big circle is India. The year is 1800. All these purple dots here are Europe. That one red dot is USA. Let's watch what happens as we travel through time by mousing over this calendar. We can watch the data travel. We see that China had a really bad period there. Ouch. Came back, bounced back though. Europe's taking off by 1900. USA is keeping up there. 1920s, you know, if you look, you can see a little bounce there in 1930s, the stock market crash. You can see a little bounce of the European and US nations. 1942, there's some real activity. If you watch this, that was Germany flying down Ukraine, really suffering. Remember, the further down it is, the life expectancy of somebody in that country is what we're looking at. And the more over to the right it is how much money. So by 1945, the average U.S. Median income for a U.S. person in inflation-adjusted dollars is $20,000. Inflation-adjusted. It's pretty interesting how little we're making. But compared to China, what is that? $600? All right, so let's travel a little further through the 50s and 60s. By the 70s, one thing to notice is that all the dots have gotten a little bigger. Population worldwide has kind of gone up. The other thing is all the dots have moved north. The life expectancy worldwide has increased by 1970. Penicillin has finally gotten everywhere. Let's keep going in time. By 1990s, the amount of money being added by China and India is pretty stunning. And watch how it cruises through 2009. We only have data through 2009. That's why China and India matter as markets. Those are huge dots moving so that there's a whole bunch more middle-class income than there had been. What's suffering is our blue dots, Africa. So the orange dots are South Asia, the brown dots are East Asia, the red dots are the Americas, purple dots are Europe, blue is Africa. Africa is still, their life expectancy, although way better than 1800, is still painfully low, and the income is just not proportionate to the rest of the world. Pretty fascinating data. One thing to take away that's pretty fascinating about this data is that, I mean, if you think, a lot of times people say you have to be like a really special mathematician to be able to visualize four-dimensional data. This data's got life expectancy, income per capita, geography, population, and geography,
Time.
and time. Thank you, and time. So you guys are all apparently mathematical geniuses. You just visualized five-dimensional data. Pretty cool. Let's look at some more examples. One of the things that, what's this? So this is something that was published in the New York Times. It's kind of a calendar view. There's a couple different cool calendar views where they're mapping waterfall and drought over time. That would be too depressing for me to look at. Here's an interesting visualization. How states of, this was again a publication in the New York Times, very cool graphic showing how the nation became red and blue and tracking particular regions. Let's look at Sorry. Let's find a fun one. Oh, this is a good one. So this is trying to visualize prime numbers and actually abundant and deficient numbers. So on the x-axis, we just have different numbers, and for we have a bunch of curves. The first curve just goes up and down for each value of 1. The second curve goes for each value of 2. The third curve is value of 3. So as we hover over a particular number like 8, we see a set of different curves get highlighted. And if you hover over a prime number, the only two curves you see highlighted are the 1 and itself curve. We can zoom out and watch
That's
it.
pretty cool. Huh?
Yeah, it's that's what I wanted to hear. It took me an hour and a half. Yeah, that's pretty cool.
Alan, do you still have the thing that you made when you first started here with the piano sounds?
I don't know if I have it. I could look for it. Yeah,
Pretty fun.
that was another example. I don't have it handy. It was a bar chart. I introduced some tones so that as you moused over the different bars, it would go ding 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 ding. Let's try another one. So there's a lot of cool different mapping. Oh, sorry, politics again. Politics. But there are cool mapping tools. Mapping is hard because data is hard. It's hard to get good data of regions of countries. But there are tools out there, and there's a great blog post on that. Well, this is a cool sunburst. So this is trying to visualize different ways that people might reach a particular web page in your page. So the question is, did you start at your home page and then, so it's one way to get to this particular page was to start at the home page, do a search, visit this page, this page, this page, and then this page. Or you could go directly to that link, but only 2% of visits began with that page. So the takeaway here is that we're looking at hierarchical data and stacked data in an interactive, fun way. So it's not so much whatever particular value you happen to be seeing, but it's the idea that, oh yeah, just with mousing over, I can learn cool things about what I might be interested in.
Is there anything on global warming?
Oh, there's several. There's many. I could find too many. I don't want to go there. We're all gonna die. Let's see. these are kind of fun. These are mapping with curves, associations between different objects in a sort of and I think you can even do some spinning or something. No, not this one. But it's the point being that you can maybe follow that whatever this object over here is somehow associated with this object over here. Another.
This map.
Oh, this was fun. So this was mapping repetition in people's speeches. So this is Bob Dylan's how many times was cannonballs fly. So that's repeated. You can see by the breakdown that gets repeated twice, and times gets repeated only 1, 2, 3 times, and then so you see patterns in speech. So, for example, if you look at Obama's speech from something, you see that there's this. He emphasizes we must. It's sort of kind of interesting to read the speech this way. We must act. We must act in knowing that our work will be important. And you can see trends in the way that they use speech to communicate to people. That's another interesting way to. The point being, that's another way. Interesting piece of data presented in a new and creative way.
In the chapter for you, there's a few that I've seen that I like. If you like looking at algorithms, some people here might.
Okay, it's in the link chat there.
Right, yeah. So,
Oh,